Every year, over 30 million tons of bamboo are harvested worldwide. But did you know that this seemingly ordinary grass can transform into steel, silk, and even concrete? It grows faster than any tree, absorbs more carbon dioxide than a forest, and doesn't require replanting. But the most interesting part is what's hidden inside its fibers. In this video, we'll show you how giant green stalks travel from plantations to ultra-durable flooring and delicate fabric. And if you watch until the end, you'll learn one shocking fact that will change your perception of the future of ecology. It all begins on vast bamboo plantations, covering millions of acres around the world. These are not chaotic thickets, but carefully managed farms. Unlike forests, bamboo does not require replanting. When one stalk, or culm, is cut, its extensive root system, called a rhizome, immediately sends up new shoots. This makes it one of the most sustainable resources on the planet. One plantation can yield harvests for decades without harming the soil. Moreover, a bamboo forest absorbs 35% more carbon dioxide and produces 35% more oxygen than an equivalent area of trees. Harvesters, armed with simple machetes or handsaws, selectively cut only mature stalks, whose age can be easily determined by color and texture. Young shoots are left to grow further, ensuring the continuity of the cycle. One such mature stalk can reach 60 feet in height and weigh over 100 pounds, making its transportation from the plantation to the primary processing plant a complex logistical task. When these green towers arrive for processing, their radical transformation begins. First, the long stalks are cut into manageable sections. Then, they are fed into a special machine that, with a deafening crack, splits the round sections into long strips. The next step is to remove the outer green skin and inner nodes, leaving clean, light bamboo planks. But inside these planks still lurks an enemy of durability: starch and sugar, which are a favorite food for insects and mold. To get rid of them, the planks are submerged in huge vats of boiling water or a hydrogen peroxide solution for several hours. This hot bath not only sterilizes the bamboo, but also washes out all the nutrients. After this, the planks are sent for drying. Some producers dry them in the open air, but for industrial scales, they are loaded into giant kiln dryers, where they spend several days until their moisture level drops from 50% to an ideal 8 or 10%. This stage is critically important, as any residual moisture can lead to warping and cracking of the finished product. But the journey from a 60-foot pole to a smooth floorboard requires even more impressive engineering. The dried planks pass through milling machines that give them a perfectly rectangular shape. Then begins a process similar to making industrial lasagna. To create horizontal flooring, the planks are laid in a single layer and glued under pressure. For vertical flooring, the planks are placed on their edge and pressed from the side, creating a denser pattern. But the real marvel is the strand-woven technology. Here, the bamboo planks are not just glued together, but completely shredded into long fibers, mixed with an environmentally friendly resin, and loaded into huge steel presses. Under infernal pressure, reaching 3,000 pounds per square inch, and high temperature, this mass transforms into an extremely dense, monolithic block. The hardness of such flooring on the Yanka scale can exceed 5,000 units, making it more than 3 times harder than oak, and more resistant to scratches and dents than most traditional wood species. However, hardness is only one of bamboo's facets. Its other superpower is the ability to transform into something incredibly soft and silky. The process of creating bamboo fabric is a true industrial alchemy. The most common method, known as the viscose process, begins with grinding the bamboo raw material into a cellulose pulp. This pulp is then submerged in a sodium hydroxide solution and then carbon disulfide, which turns it into a thick, viscous liquid. This liquid, resembling honey, is forced under pressure through the finest holes of a metal plate called a spinneret. Imagine a microscopic shower. Emerging from the holes, the thin streams enter a bath of sulfuric acid, where they instantly solidify, turning into endlessly long fibers. These fibers are then washed, bleached, dried, and twisted into yarn, from which fabric is woven. Despite the complex chemical process, the final product is biodegradable and has unique properties. It is extremely soft, hypoallergenic, has natural antibacterial properties, and breathes wonderfully, making it ideal for clothing and bedding. The global bamboo market is colossal and is projected to exceed $100 billion in the coming years. Annually, over 30 million tons of bamboo are harvested worldwide, and this figure is only growing. From kitchen cutting boards and toothbrushes to construction scaffolding capable of supporting the weight of concrete and elements in premium class cars, this giant grass demonstrates its versatility. It is a testament to how nature, multiplied by human ingenuity, can offer sustainable, strong, and beautiful solutions for countless tasks, turning a fast-growing straw into the gold of the modern world. Bamboo grows both in the wild and on specially created plantations. Its natural habitat mainly covers tropical and subtropical regions of Asia, where it is an integral part of local ecosystems. At the same time, thanks to its unique properties and wide range of applications, bamboo is actively cultivated on plantations around the world. It is cultivated for the production of building materials, textiles, paper, interior items, and as a source of biomass. In the wild, there are over 1,000 species of bamboo. It is a perennial evergreen plant belonging to the grass family. Bamboo is known for its extremely fast growth. Some species can grow several tens of centimeters per day. Bamboo blooms very rarely, and after flowering and fruiting, the plant usually dies. Growing bamboo requires certain knowledge and care, including proper planting, regular watering, and choosing the right variety for specific climatic conditions. There are even ornamental types of bamboo that are grown in gardens and at home. Ever wonder where your old laptop goes after you toss it out? Every single year, millions of tons of electronics like these end up getting recycled. But hey, it is not just trash. Inside, there is a real treasure trove. Gold, silver, copper. And right alongside that, toxic hazards, mercury, lead, and batteries just waiting to burst into flames at any moment. How do they protect your data on those old drives? Why are the workers dressed like astronauts? See for yourself the shocking but super important journey your old gadget takes, from the conveyor belt all the way to extracting precious metals. It is a sight that will totally change how you think about unwanted electronics. Keep watching. Specialized companies or collection points take in old laptops from regular folks and businesses. The devices get checked to see if they still work. Laptops that are still working might get fixed up and resold, or donated to charities. Large batches of laptops are transported to specialized facilities. There, trucks unload containers full of laptops. Workers using forklifts move them to the sorting area. Then, workers wearing protective gloves and special suits look over each laptop. Yeah, safety is a really big deal here. The people on the sorting line wear protective gloves and suits for a few reasons. Old laptops might have components containing lead, like in the solder, or mercury in the fluorescent backlights of the displays. Touching these without protection could lead to poisoning. Cadmium and beryllium are dangerous if they touch your skin or if you breathe in the dust. These heavy metals are used in batteries and circuit boards. Some laptop parts, especially broken screens, can have sharp edges that could easily cut your hands. And during disassembly, small components can break off and go flying. Even when a laptop seems dead, some capacitors can still hold a residual charge. Touching them without protection could give you an electric shock. Special anti-static suits and gloves prevent damage to electronic components from static electricity. When the laptops are shredded, a lot of toxic dust is created, which can contain microscopic particles of metal and plastic. To avoid breathing this dust in, workers wear masks or respirators. Working laptop models are set aside during sorting. They can be repaired and sold. The rest are sent off for recycling. Lithium-ion batteries are removed by hand because they can catch fire or explode. During shredding, or if they get damaged mechanically, the battery can overheat and ignite. Lithium reacting with air or water can release flammable gases. Also, inside the battery, there are toxic electrolytes that can cause chemical burns or poisoning. If a battery gets deformed, these substances can leak out and get into the environment. That is why workers manually unscrew the panels and take out the batteries. If the battery is built in, they disconnect it using a special tool. The removed batteries are placed into heat-resistant containers filled with sand or other non-flammable materials. They are stored in well-ventilated areas, away from other waste materials. Recycling the batteries happens separately from the rest of the laptop. They go to specialized plants where the metal casings are shredded. From the internal materials, like nickel, cobalt, and lithium, useful components are extracted for reuse. After the batteries, the next critical step is removing the hard drives. Why are hard drives taken out separately? Well, the thing is, even if the laptop does not work, data can still be stored on the drive. And corporate or government laptops might contain sensitive data, so the hard drives have to be destroyed following special procedures. Some drives have moving mechanical parts, like platters and motors, which are processed separately. Other drives are made of memory chips that need a different recycling technology. Workers unscrew the laptop casings and remove the drives by hand. In some models, solid-state drives are built right into the motherboard. In that case, they are either desoldered or broken off along with the board. After that, there are 3 ways they physically destroy the drives to ensure data security. They are either shredded in special shredders, turning them into tiny metal fragments, or they are wiped using magnetic degaussers, which erases the data permanently, or they are melted down into metal ingots. The aluminum casings from hard disk drives are sent off for remelting. The magnetic platters have coatings of gold, platinum, and cobalt, which are extracted using chemical processes. Solid-state drive controllers contain copper, silver, and rare earth metals. These are also extracted for reuse. Once the batteries and hard drives are out, the laptops do not pose a serious fire or data security threat anymore. Now, they can be sent over for automated case disassembly. The laptops move along a conveyor belt, passing one by one under an automated press. Powerful hydraulic plates with up to 5 tons of force squeeze the casing, causing tiny cracks in the fasteners. One hit, and the top panel separates from the bottom, leaving the internal components accessible for further processing. The laptops keep moving down the line. Mechanical arms with thin metal fingers hover over them. Each arm is equipped with an automatic screwdriver unit that spins at up to 5,000 revolutions per minute. In just 4 to 6 seconds, the robot unscrews the screws and carefully removes the keyboard, speakers, and cooling system heatsinks. When the laptop reaches the next module, 2 pneumatic grippers grab onto the screen. A blade with a high-precision control system runs along the edges, cutting through the plastic fasteners. A barely audible crack, and the display is separated. Now the laptop is almost empty, with only the main guts left, the motherboard. Another arm removes it, using vacuum suction cups to lift the board and place it into a separate container. The whole process takes less than 2 minutes, and what was once a whole laptop is now just separate parts, ready for sorting and further recycling. The conveyor moves the separate laptop parts to sorting stations. Both robots and people work here. Plastic case panels are directed one way. They pass through special scanners that identify the type of plastic. Some types of plastic can be reused. Others are disposed of as regular waste or converted into fuel for industrial plants. Metal parts, like case frames, fasteners, and heat pipes, go through magnetic separators. Ferromagnetic metals, like iron and steel, are separated using powerful magnets. Non-ferromagnetic metals, like aluminum and copper, are sorted using induction detectors. Glass from the display screens goes into a shredder, where it is broken into small fragments. After that, special equipment cleans the glass granules of impurities. The resulting material can be used to make new displays or building materials. Motherboards, graphics chips, processors, and other integrated circuits are collected separately. They are checked to see if they can possibly be reused. If the circuits are still usable, they are sent to the secondary market or for refurbishment. Most electronic components, however, end up being recycled. To do this, they are sent to special furnaces where high temperatures burn off the organic materials. Only the metals remain: gold, silver, copper, palladium. They are extracted using chemical methods, purified, and returned to manufacturing. Laptops also contain hazardous substances: lead, mercury, cadmium, lithium. These cannot be allowed to enter the environment, so they undergo special processing. The fluorescent lamps from displays, which contain mercury, are separated under sealed conditions so that mercury vapor does not escape into the air. The recovered mercury is reused, for example, in medicine or in making thermometers. The lithium batteries, which were removed in the initial stage, are transported to separate plants. There, they are dismantled, and lithium and other useful elements are extracted. The resulting materials are used in the production of new batteries. Lead, found in solder, is melted down under controlled conditions, separating it from impurities. The entire process of dismantling, sorting, and recycling a laptop can take anywhere from a few hours to several days, depending on the scale of the facility and the technological process used. After sorting, all the materials are distributed into separate containers, or large industrial bins, depending on their type and the next steps in processing. In the plastic containers, you will find fragments of casings, keyboards, touchpads, which might be black, gray, or silver. The plastic is sorted by type: acrylonitrile butadiene styrene, polycarbonate, polypropylene. In the bins for metals, you can see piles of parts. Here lie aluminum frames and lids from laptop cases, copper heat sinks and wires, steel fasteners and screws. Containers for electronics are filled with the removed motherboards, graphics chips, random access memory modules. It all looks like a heap of complex green and blue boards with gold contacts and copper traces scattered across them. In separate containers for displays, there are dismantled screens with fragments of glass and metal frames. Sealed containers for hazardous materials hold batteries. Mercury lamps and capacitors containing lead are stored separately. These are often kept in special zones with warning signs about toxicity and explosion risks. After sorting, all these materials need to be transported to specialized plants where they will undergo further processing and preparation for reuse. To save space in trucks and containers, some materials are compressed. For example, plastic is shredded into granules or pressed into large bales. Metals are compressed into dense cubes. Glass is crushed and packed into bags or containers. Electronic components are stored in large containers without being compressed, since they still need to undergo chemical treatment. Lithium batteries are placed in special non-flammable containers, often filled with sand or expanded clay pellets to prevent ignition. Mercury lamps are transported in sealed boxes that prevent mercury vapors from getting into the air. The materials are loaded onto trucks, trains, or ships, depending on the distance and the type of material. Large metal cubes are lifted by forklifts and stacked in trucks. Containers with plastic and glass are transported in trailers or sea containers. Electronic components might be transported in special containers with shock-absorbing protection. Metals are sent to metallurgical plants, where they are melted down and purified. Aluminum, copper, and iron can be reused in manufacturing electronics, cars, or building materials. Plastic goes to plastics recycling plants, where it is shredded, melted down, and used to produce new casings for electronics, furniture, or packaging. Glass goes to facilities that manufacture new screens or building materials, for example, insulation made from recycled glass. Electronic circuit boards are delivered to plants specializing in extracting precious and rare earth metals. There, the integrated circuits are dissolved in chemical solutions to extract gold, silver, palladium, and other valuable metals. Batteries head to facilities where lithium, nickel, and cobalt are extracted for manufacturing new batteries. Hazardous waste goes to special landfills or chemical plants, where toxic substances are neutralized or rendered harmless under controlled conditions. After several months or even years, the materials from a recycled laptop can end up back in production, as part of a new device, building, or car. Some large recycling facilities specialize narrowly, for example, dealing only with computer equipment or mobile devices. Others recycle almost all types of electronics, including large household appliances. Imagine a plant spread out over 11 million square feet, where thousands of specialists work every single day to assemble an aircraft made up of more than 4 million parts. Here, in Toulouse, France, giants of the sky are born, from the legendary A380 to the cutting-edge A350. Parts for these aircraft come in from all over the globe. Wings from Britain, the fuselage from Germany, and engines from the United States. This is not just a plant. It is the heart of European aviation and a true marvel of engineering. And now we are going to take a look inside. The Airbus plant in Toulouse covers an area of over 11 million square feet. Now, that is an impressive size for any manufacturing complex, and especially so in the aviation industry. This plant produces not only the A380, but also other aircraft models from the company, like the A350. To produce these technological wonders, Airbus uses more than 2,000 workstations equipped with the very latest technology. This plant is the heart of Airbus aircraft production and a complex logistics hub, where every stage of aircraft manufacturing is its own form of art. The Airbus plant in Toulouse was actually founded way back in 1946 under the name Aerospatiale. Initially, it was a French company specializing in aviation manufacturing, and it laid the groundwork for the future Airbus plant. All the early stages of the plant's operation involved creating aircraft for both military and commercial needs. The Toulouse plant was strategically chosen for its location, which provided convenient access to transportation and logistics routes within France and across Europe. Originally, the plant focused on developing smaller aircraft, but over time, it expanded its capacity and implemented new technologies to produce large passenger aircraft. In 1970, the company Airbus Industry was established, a consortium that brought together 4 major European aviation companies: Aerospatiale from France, Deutsche Airbus from Germany, Construcciones Aeronauticas from Spain, and Air Italia from Italy. From that point on, the history of the Toulouse plant became closely linked with the development of the aviation industry in Europe. This is where the production process for Airbus aircraft began. Aircraft that would become significant competitors to giants like Boeing. Over the following decades, the Toulouse plant expanded multiple times as aircraft production really picked up speed. In the late 1980s and early 1990s, the plant became the main hub for producing aircraft like the Airbus A300, the first certified wide-body aircraft, and the A320, one of the most popular aircraft in the history of civil aviation. Over time, the Toulouse plant became the primary production center for models like the A330, the A340, and the A380, that huge double-decker aircraft that became a symbol of Airbus. In the 2000s, the Toulouse plant underwent major changes and modernization to handle the production of newer models, like the A350, which was introduced to the market in 2013. For this purpose, new assembly halls were built at the plant, including large facilities for assembly and testing, along with new automation systems to boost production efficiency and precision. Manufacturing the Airbus A380 is such a complex and detailed process that it requires innovative methods and technologies for its assembly. Just imagine, each aircraft produced at the plant consists of over 4 million individual parts. These parts are supplied from all around the world, from China to the United States. For example, the main fuselage components come from Germany, the wings from Great Britain, and the tail section from Spain. That is right, the Toulouse plant primarily handles the final assembly of the aircraft. This is standard practice for major aircraft manufacturers. Major engine manufacturers, like General Electric and Pratt & Whitney, supply the powerful jet engines for Airbus aircraft. Additionally, various aviation systems and components arrive from the United States. China is a key supplier of various metal parts, plastic components, and other materials for the aviation industry. Furthermore, Chinese companies provide certain aerodynamic parts. Other parts, including structural elements and fuselage details, are supplied by various European countries, such as Germany, Italy, Spain, and Great Britain. Well-known Canadian companies, like Bombardier, also supply components for different Airbus models, notably for the A220. After being manufactured, these parts are transported to the plant in Toulouse, where they are assembled into a single, complete unit. This often takes several weeks, and the large components are transported using specialized methods, like ships or air transport. The Airbus plant in Toulouse covers an area of 11 million square feet. It is one of the largest aviation manufacturing sites in the world. First, inside the plant's enormous assembly halls, the aircraft fuselage is put together. This is the main body of the aircraft, composed of several large segments that are delivered separately. Each fuselage segment is a major part of the structure, joined together with the others using cranes and specialized assembly machines. A crane lifts the parts, and they are carefully connected using special bolts and welding techniques. This is how the frame structure begins to take shape. Although it is not yet in its final form, once the main fuselage sections are assembled, the wings are brought into separate areas for installation. These wings are heavy, and their installation also involves the use of hydraulic cranes. When the wings are ready, they are attached to the main fuselage structure. Special attention is paid to this stage because the join between the fuselage and the wings is a critically important part that affects the aircraft's aerodynamics and safety. The installation of all the necessary systems, electrical, hydraulic, and avionics, also happens during this phase. Parts are integrated in special clean rooms to prevent any damage or contamination. This is a highly precise process, as all the elements, like cables, pipes, and computer systems, must be correctly positioned within a limited space. Robotic systems are often used at this stage for the precise placement of these elements. Once the aircraft structure is nearly complete and all internal systems are connected, it is time to install the engines. This is another critically important step, as the engines play a significant role in the aircraft's overall stability. Large hydraulic mechanisms and cranes are used to lift the heavy engines and precisely attach them to the aircraft structure. This also demands a high degree of precision and care. As soon as the aircraft is assembled and the engines are in place, it undergoes a series of tests and checks. On the ground, they conduct tests on the braking systems and check the aircraft's response to mechanical stresses. All these operations take place on enormous testing grounds, which allow for trials involving various loads and speeds. At the same time, the functionality of all the aircraft systems is verified. The testing area itself covers about 2 million square feet. After all the tests and adjustments are done, the aircraft moves on to the finishing stage, where it gets painted and the final details are added: window sealants, stripes, logos, and other design elements. Before the paint is applied, the aircraft is thoroughly cleaned to remove any contaminants, grease residues, or dust. Following this, the metal surface is treated to ensure better paint adhesion. An important step is the application of an anti-corrosion coating, which protects the aircraft body from oxidation and other harmful factors. This coating is applied using special sprays or spray guns to create a uniform protective layer. The aircraft is then painted in several layers. Most often, special polyurethane paints are used, which provide a durable, resistant coating. These are applied using rotary atomizers, which allow for even distribution of paint across the entire surface. The aircraft is placed inside a special painting hangar, sort of like a large enclosed area, where the necessary temperature and humidity levels are maintained to ensure proper paint adhesion to the surface and facilitate quick drying. After the base color is applied, a top coat is added, which provides extra protection against atmospheric elements and also gives the aircraft a glossy finish. This layer also adds resistance to ultraviolet rays, preventing the paint from fading in the sun. After painting, the aircraft are inspected for any defects. If any cracks or bubbles appear in the paint, they have to be corrected. In the final stage, airline logos or special liveries are applied to the aircraft. This might involve not just applying paint, but also installing special decals or applying a protective film to the surface. This process can take up to several weeks for a single aircraft, depending on the size and complexity of the livery. In total, painting a complete Airbus aircraft requires about 3,300 pounds of paint. The process of installing the cockpit is one of the most complex and precise operations. The aircraft cockpit, especially in models like the A350 or A380, contains hundreds of different sensors, control systems, displays, and other technical elements that must be precisely configured. Altogether, a cockpit can contain up to 5,000 different parts. Interestingly, the assembly of the cockpit takes place separately from the main aircraft body. This is done in special workshops where the cockpit is fully equipped before being transported for final integration into the aircraft. The entire cockpit installation process takes several days and demands the highest level of precision, because any malfunction in the control or navigation systems could lead to serious problems during the aircraft's operation. Another crucial aspect is the integration of avionics, which are the aircraft's electronic control systems. These systems allow pilots to monitor flight parameters, engine status, the situation in the sky, and perform other critically important functions. Installing the avionics takes anywhere from several days to several weeks, depending on the complexity and type of the aircraft. More than 10,000 people are involved in the aircraft assembly process, including engineers, technicians, testers, and other specialists. The production cost for a single A380 aircraft is around $445 million United States dollars, making this project one of the most expensive in the world of aviation. Just for the development of new technologies and the improvement of automation processes, Airbus spends millions of dollars every year. Every single year, more than 170 million old refrigerators are disposed of throughout the world. However, what actually happens to them once they disappear from our kitchens? Refrigerants that can damage the ozone layer, hundreds of pounds of metal, plastic, and even precious metals all require specialized processing. Did you know that old refrigerators contain gold, silver, and copper that can all be given a second life? And some models are even sold to poorer countries instead of being recycled. Please stay with us to see how junk is turned into a resource and discover who is making millions of dollars in the process. In the United States of America, there are several ways old refrigerators are collected for disposal, ensuring safe and environmentally responsible recycling. Some large retail chains, such as Best Buy, offer programs to recycle old household appliances. When you purchase a new refrigerator, they can take the old one away for further recycling. These programs often come with restrictions, for example, no more than 3 appliances per day from a single household. There are a few reasons for limits on how many appliances can be recycled. The first reason is logistics and the burden on the system, since recycling centers have limited capacity. If everyone could drop off any number of appliances, the collection and recycling processes could become overloaded. These programs are also intended for individual consumers, not for businesses or resellers. The limits also prevent hauling companies from making free use of disposal services. The third reason concerns cost optimization. In many cases, recycling is subsidized by the government or by private companies. The restrictions help control expenses and distribute resources evenly. The final reason is environmental responsibility. These programs often encourage people to switch to energy-efficient devices rather than simply throwing away large quantities of appliances. It is a kind of balance between convenience for consumers and the operational efficiency of the recycling centers. In many cities and districts, there are municipal collection points for large household appliances. Consumers can bring their old refrigerators to these points, where specialized companies pick them up for recycling. These collection points can be stationary or mobile, which makes it more convenient for residents. Some energy companies also offer programs for disposing of old, inefficient refrigerators. They may provide financial incentives or free appliance removal to encourage consumers to switch to energy-saving models. There are also private companies that specialize in collecting and recycling large household appliances. They offer services to remove old refrigerators directly from the consumer's home for a certain fee. These methods of collecting old refrigerators support the responsible handling of electronic waste, ensuring proper recycling and minimizing negative impacts on the environment. After collection, old refrigerators are taken to specialized recycling centers, where they are sorted and prepared for disposal. This process unfolds in several main ways, which we will describe right now. Many major cities have specialized facilities that accept old appliances directly. For instance, in the United States of America, such facilities operate under programs focused on the responsible recycling of electronics. In some situations, refrigerators are first sent to warehouses or designated lots where enough units are accumulated for subsequent mass recycling. This saves on transportation costs and streamlines logistics. Some large brands, such as Whirlpool or LG, run their own recycling programs. They take back old refrigerators, break them down, and reuse some of the materials in the production of new appliances. Sometimes, old but still functioning refrigerators are sold or transferred to less developed countries. This practice is considered controversial because such equipment can consume a lot of energy and may contain hazardous substances. How do you feel about this issue? Is it better to have a refrigerator that poses potential harm, or is health more important than questionable humanitarian aid? In Europe, there are strict regulations regarding the recycling of household appliances. For instance, under the Waste Electrical and Electronic Equipment Program, refrigerators are transported to certified centers, where they are taken apart into environmentally safe components. At every stage of this process, safety regulations must be observed, because refrigerators contain refrigerants and other potentially harmful substances that cannot simply be dumped in a landfill. Before a refrigerator is sent for dismantling, its technical condition is assessed. Models that still work can be repaired and resold, or donated to charitable organizations. Faulty or obsolete models are immediately directed to further processing. Next, refrigerators are categorized, since different models contain different materials and refrigerants. They are divided into industrial refrigerators, household refrigerators, and refrigerators containing harmful freon. After that, refrigerators are checked for the presence of hazardous gases and liquids. Freon and other refrigerants are removed because they require special disposal methods, as they deplete the ozone layer. Lubricants are drained, since they can contain heavy metals. Before extracting freon, technicians place the refrigerator in a designated treatment area, where they check which specific refrigerant is used. Technicians connect the refrigerator to a vacuum pump, which creates pressure inside the system and forces the freon to flow in the required direction. The refrigerant is drawn out through specialized valves, after which the gaseous freon is collected in sealed containers, while the liquid freon is filtered and can either be used again or sent for chemical recycling. The freon that is collected undergoes purification to remove oil, moisture, and metal particles. After that, it is either destroyed or reused in cooling equipment. Older banned refrigerants must not be released into the atmosphere, so they are incinerated in special high-temperature installations that break them down into harmless components, or they are converted into newer, safer gases through chemical reactions. All of this happens at certified facilities because mishandling freon can cause damage to the environment. Once the freon and other refrigerants have been dealt with, it is necessary to drain the lubricants from the refrigerator. These fluids contain pollutants that can harm the environment. The lubricant in a refrigerator is mostly in the compressor, which is responsible for circulating the refrigerant. During operation, it mixes with freon, so removing both substances often occurs simultaneously, although it depends on the specific model. Before draining the lubricant, the compressor is removed or punctured so that the fluid can flow out freely. The lubricant then either drains by gravity into a collection tank, or it is pumped out by a vacuum device. Special containers are used to prevent spills and the evaporation of dangerous substances. The collected fluid is then purified of any remaining freon, metal particles, and other impurities through settling and filtration. After purification, the lubricant can be reused in compressors if additional cleaning is performed. If it cannot be recycled, it is incinerated in special furnaces. It can also be applied in certain industries, for instance, in the production of technical lubricants. This is carried out at specialized facilities to prevent leaks of harmful substances into the environment. Modern refrigerators contain electronic boards, displays, and battery elements. Workers remove these parts by hand because automated conveyors cannot handle such components without damaging valuable materials. Prior to shredding, refrigerators undergo inspection. Wiring, plastic parts, and insulating panels are taken off. These materials are sorted for further recycling or safe disposal. In general, human oversight is required at every step to ensure safe and clean disassembly. However, certain processes are automated. For example, shredding metal housings or compressing plastics. The external body of a refrigerator is usually made of steel or aluminum sheet. It is separated either by hand or by hydraulic machines and sent for shredding. Compressors and condensers have a high content of non-ferrous metals, such as copper and aluminum, so they are taken apart separately. Copper and aluminum are then sent for smelting and used in new electric devices. Refrigerators also contain many plastic parts, such as internal panels, shelves, bins, and door gaskets. Workers remove these elements by hand because the plastic must be sorted by type. Certain types of plastic are recycled into pellets, which are later used to manufacture new products. Some refrigerator models feature glass shelves or glass doors in display-style refrigerators. This glass is removed manually, sorted by quality, and sent for remelting. Modern refrigerators include control boards, displays, wiring, and batteries. Electronic parts are taken out and transferred to specialized facilities for extracting precious metals like gold, silver, and palladium. Most refrigerators have foam polyurethane or polystyrene foam as insulation. It is removed or shredded, and some of that material can be used as filler in construction or for manufacturing new insulation. Metals go to metallurgical plants. Plastics are compressed into briquettes and sent to recycling facilities. First, the plastic parts, meaning bins, shelves, and outer components, are placed into special shredders. Inside these machines, blades or rotary cutters chop the plastic into tiny pieces no more than 2 inches in size. Next, the plastic fragments are washed in water baths to remove dust, adhesive residue, labels, and other impurities. Some plastics undergo separation, during which they are divided by density. For example, lighter polymers float to the surface, while heavier ones sink to the bottom. The cleaned plastic is sent through powerful drying units to ensure it has no excess moisture, since moisture can reduce the quality of the recycling process. The dried plastic is then fed into hydraulic or mechanical presses, where it is compacted under pressures of up to a few hundred short tons. This process occurs without heating, so the material does not melt but simply becomes more dense. The pressed plastic is formed into briquettes weighing from a few pounds to a few dozen pounds, depending on what clients need. The finished briquettes are wrapped in film or secured with metal straps so that they do not fall apart during transport. They are then shipped to factories, where the plastic will be melted and converted into new items, such as plastic containers, furniture, pipes, or even parts for new refrigerators. This method conserves space during transport and reduces logistics costs, since pressed plastic occupies several times less volume than loose fragments. Glass is remelted and used in new glass products. Electronic parts are recycled separately, and precious metals are extracted from them. Insulation materials are partly disposed of or reused. Thanks to modern technology, most materials from old refrigerators get a second chance at life. 850 horsepower. That is the power output of the hybrid Lamborghini Revuelto. This is almost like having the force of 2 average tanks. Whenever you see a Lamborghini on the road, it is impossible not to turn your head. This is a car that shouts success and style, and it does so very loudly, thanks to its V12 engine. A Lamborghini is not merely an automobile. It is a symbol of status, luxury, and wildly high speed. However, this car is not just beautiful. Its heart is a genuine masterpiece of engineering. Shall I tell you about the engine? Lamborghini is renowned for its naturally aspirated engines that roar like a wild beast. The brand's most famous motors are the legendary V10 and V12, which provide not only insane power, but also an incredible sound that sends chills down your spine. The V12 engine was already present in the first Lamborghini 350 GT from the year 1963, and it remains the company's signature to this day. The establishment of Lamborghini was not merely a business project, it was an act of revenge. In the small town of Sant'Agata Bolognese, under the blazing sun of Emilia-Romagna, a company was born that challenged none other than Ferrari. Ferruccio Lamborghini was a successful businessman who became wealthy through the production of tractors. He owned an entire collection of sports cars, but he had problems with the Ferrari 250 GT because its clutch often broke down. One day, Lamborghini decided to express his dissatisfaction directly to Enzo Ferrari. He proposed improving the cars, but he was met with this response. "Ferruccio, you are just a farmer. You should focus on tractors and stay out of sports cars." Those words were the point of no return. Lamborghini resolved to build his own supercar that would surpass Ferrari. He hired the best engineers, including Giotto Bizzarini, the person who had developed engines for Ferrari. The team created that same legendary engine that became the heart of the first Lamborghini 350 GT. Even then, the car showed that Lamborghini was not joking around. It was faster and more comfortable than Ferrari. The first car was a success, and the company began to grow rapidly. Within only a few years came the legendary Misura, then the Countach, the Diablo, the Murcielago, and the Aventador. And now, for 60 years, Lamborghini has continued to be a symbol of status, aggression, and an engine's ferocious roar. The main Lamborghini factory covers 1,743,752 square feet. That is nearly the size of 23 soccer fields. This place is a genuine temple of speed and engineering artistry. All the critical steps in creating supercars are concentrated here. Massive pavilions equipped with ultra-modern technology merge with the craftsmanship of hand assembly, which remains an unchanging tradition of the brand. The factory includes a materials laboratory where carbon fiber is tested, paint booths where each automobile receives a perfect finish, and the exclusive ad personam division that allows clients to customize their Lamborghinis down to the finest detail. Every vehicle undergoes strict quality tests before leaving this temple of speed, bound for owners all over the world. In the year 2023, Lamborghini set a production record for the entire history of the company. 8,405 brand new cars rolled off the factory line. Every contour of the body is designed not only for aerodynamics, but also for maximum visual impact. The low profile, the aggressive front end, the sharp edges, and the massive air intakes all form the image of a wild predator ready to pounce. The signature guillotine doors on the Aventador or Revuelto models are an unforgettable sight. They lift upward. The moment you open them, you already look like a movie star. Buying a Lamborghini is not simply about money. It is about a way of life. Lamborghini owners want to stand out, be at the center of attention, and experience an adrenaline surge each time they press the gas pedal. It is no surprise that among these owners are soccer players, actors, business people, and even princes. Lamborghini has always been synonymous with exclusivity. Production is limited. Most models are released in small batches, and some appear in limited runs of 10 or 20 units. For example, the Lamborghini Centenario was produced in only 40 units, 20 coupes, and 20 roadsters. Lamborghini uses only premium materials, most of which come from the world's top suppliers. The main material is carbon fiber. Did you assume the body was made of metal? It is not. Carbon fiber is an ultra-strong yet lightweight material made up of extremely thin strands of carbon, each roughly 10 times thinner than a human hair. It is stronger than steel, but weighs several times less, making it ideal for supercars. Carbon fiber begins with polyacrylonitrile threads, which are a synthetic material similar to plastic. The fibers are heated in special furnaces with oxygen, which alters their chemical structure and makes them thermally stable. Then the fibers move into furnaces without oxygen, for instance in a nitrogen atmosphere. Under extreme temperature, they lose all inorganic components and are left as nearly pure carbon. These carbon threads are then treated to bond more effectively with polymer resins. The finished fibers are woven into fabric or laid out as ribbons. The carbon fabric is infused with resin and then shaped as needed. Lamborghini uses forged composites technology, where the fibers are arranged randomly, resulting in parts that are even lighter and stronger. The form goes into a high-temperature, high-pressure autoclave, where the composite hardens and gains extraordinary rigidity. Imagine strands thinner than a hair passing through furnaces at 3,632 degrees Fahrenheit. What comes out is a black thread that is 5 times stronger than steel, yet 7 times lighter. Instead of a conventional steel component weighing 33 pounds, Lamborghini gets a carbon substitute that weighs 6 pounds, while preserving the same strength. This material enables Lamborghini to craft bodies that are light, strong, and fast, reducing the vehicle's overall mass and boosting its aerodynamics and performance. Aluminum is sourced in Europe, especially from Italy and Germany. It is utilized for fabricating the chassis, the load-bearing body components, and various structural parts, since it is both light and strong. Suppliers deliver aluminum as sheets, profiles, or ingots. When it arrives as ingots, it is melted down and cast into blanks. Aluminum is melted in special furnaces at around 2,232 degrees Fahrenheit. The molten metal is poured into molds under high pressure. The casting solidifies in a matter of seconds and is then removed. The cast pieces are ground, excess material is trimmed off, and they undergo heat treatment to enhance their strength. Using aluminum makes the frame about 40% lighter than a steel alternative. Lamborghini's press machines can produce up to about 11,000 short tons of forming pressure. A single aluminum Aventador frame weighs a mere 504 pounds, which is essential for high speeds and maneuverability. Natural Italian leather arrives from renowned tanneries in Tuscany and Piedmont. Alcantara is sourced from a factory in Umbria for the upholstery. Carbon inserts are produced directly at Lamborghini. It may require 7 or even 8 cowhides to upholster the interior of one Lamborghini. Buyers can choose any color of leather via the ad personam personalization program. Lamborghini uses premium Napa leather and aniline leather, which both have a natural texture and softness. All leather sections are handcrafted to maintain exclusivity. The leather is manually cut for each part to avoid defects or unevenness. Every seam is also stitched by hand, ensuring precise quality control. Special leather threads are used for this purpose. Each piece is dyed and treated to achieve the requested appearance and texture, consistent with the client's wishes. Once every piece is ready, it is assembled and installed in the automobile. Alcantara is a high-end synthetic material that resembles suede in both look and feel. It is widely applied in the automotive sector. Alcantara is soft, matte, and holds up better to wear than genuine leather. It is also twice as light as leather, which is critical for supercars. It does not fade, retaining its color even under direct sunlight, and it is made of 68% recycled materials. The assembly process begins with preparing the vehicle body and chassis. This involves installing a foundation constructed from lightweight metals or carbon fiber, depending on the specific model. At this stage, every mainframe element is brought together, including the suspension, the exhaust system, and other key components. This step is of the utmost importance, as it lays the groundwork for everything that comes afterward. The body is assembled by hand, using specialized tools and fixtures to ensure maximum precision and minimal gaps. Once the body and chassis are complete, the next step is the installation of the engine and the transmission. The engine is the heart of a Lamborghini, and putting it in place is an exceptionally intricate process. All Lamborghini engines are built and tested separately prior to being mounted in the car. Installing the engine also requires connecting it to the cooling system, the exhaust, and the vehicle's electronics. After this, the gearbox and the transmission system are fitted, allowing the engine's power to be transferred to the wheels. During this phase, all of the vehicle's critical systems are also fine-tuned, including the suspension and braking systems. The following stage involves installing the car's interior parts. This includes the seats, the instrument panels, the door trim, and the steering wheel. All these elements are made by hand using superior quality leather or alcantara, in the case of sportier versions, along with other exclusive materials. Every piece is finished with meticulous attention to detail, creating a truly unique cabin. For instance, Lamborghini seats are crafted by hand to accommodate every curve of both driver and passenger, providing outstanding comfort. The steering wheel is also handmade and can feature a personalized design, according to the client's preferences. Once the principal interior components are set, the car moves on to the phase dedicated to connecting the electronic systems. Lamborghini cars are noted for their cutting-edge technology, so they come equipped with intricate infotainment setups, navigation, touchscreens, and safety systems. All wires and electronic parts must be hooked up with extreme accuracy to avoid errors or malfunctions. This process can take several hours and calls for highly qualified technicians who precisely follow each component's wiring diagrams. Having finished the physical assembly of the automobile, Lamborghini proceeds with the testing stage. Each vehicle goes through a detailed evaluation on special test stands, where every function and system is checked, ranging from the engine and transmission to the brakes and suspension. This helps detect any faults or issues before the car reaches the end buyer. One of the most vital segments of testing is assessing the car's performance dynamics on the track. Here, the automobile's characteristics at high speeds are evaluated, along with its maneuverability, braking force, and stability when cornering and accelerating. Once all tests have been completed, the car returns to the assembly hall for a final inspection. If all systems operate correctly, the vehicle undergoes one last quality assessment. After this, it receives finishing touches, such as body polishing and a thorough check of every surface for paint defects. At Lamborghini, each car has its own special color, chosen during the production phase. After this, it receives finishing touches, such as body polishing and a thorough check of every surface for paint defects. At Lamborghini, each car has its own special color, chosen during the production phase. Imagine a machine that can withstand the blast of a high-explosive device, endure fire from automatic weapons, and keep rolling even with shot-through tires. This is the legendary Hummer, designed for the most dangerous missions. From operations in the Persian Gulf to modern combat zones, over 280,000 armored Hummer vehicles have become an essential part of the United States Army. How do these machines go through their testing? Which materials protect the crew? And why do they produce 70 of them per day? Let us find out. To understand why the Hummer became synonymous with invincibility, one should first look back at its history. In the 1980s, the American automobile company called A.M. General unveiled a modified Hummer that was initially developed for the civilian market. However, the troops quickly recognized its advantages for modern warfare, especially on the front lines, where soldier protection is paramount and armored vehicles became critically important for safety. A true breakthrough came after the Hummer became the main transport vehicle for the United States military during operations in the Persian Gulf at the beginning of the 1990s. Since the year 1893, over 280,000 Hummer units have been manufactured. But how can one ensure that this off-roader not only endures harsh conditions, but also provides protection in the most hazardous situations? What exactly sets the military armored Hummer apart from civilian models? Let us see how the armored components are constructed to turn these vehicles into a genuine steel shield on wheels. Military Hummer vehicles use specialized armor materials, including composite armor that combines steel plates with ceramic inserts. These materials can withstand shots from a variety of weapons, including automatic rifles and sniper rifles. Moreover, by incorporating composites, these vehicles are not only armored, but also relatively light for their size. The production rate is around 70 vehicles per day. A key structural element of the armored Hummer is the concept of plus armor. This means that multiple layers of protection are added onto the vehicle, enabling maximum defense in a wide range of combat scenarios. There are also additional design modifications, such as reinforced suspension and strengthened tires, allowing the vehicle to keep moving even if one of the tires has been damaged. Another important aspect is the strengthened floor and roof. In military Hummer vehicles, the floor is structurally protected against blasts. Special materials are used to absorb the shockwave, which reduces risk to the crew if the vehicle encounters a minefield or an explosive device. However, armor is only one part of the overall safety level. Each high-mobility multi-purpose wheeled vehicle, commonly known as the Hummer, consists of over 5,000 parts. Combat Hummer vehicles must not only be protected, they must also be real beasts capable of moving through absolutely any conditions. How is this kind of mobility achieved? In order to preserve high off-road capability and endurance, military Hummer models are equipped with a powerful diesel engine. This engine can generate substantial power that lets the vehicle easily travel through desert sands or mountainous routes, even if there is no road at all. A specialized transmission and adapted rear wheels ensure constant stability in the most extreme conditions. Many modern military Hummer vehicles integrate intelligent control systems that allow the engine and transmission to adapt to the terrain. This significantly boosts maneuverability and endurance during large-scale strategic movements. Armored versions receive steel that is 1/2 inch thick, along with bullet-resistant glass that is 1.5 inches thick. Besides armor, electronic safety systems are vital, such as sensors that detect mines and explosive devices, along with systems designed to remain fire-resistant. They add another layer of protection for the crew, which is particularly critical in combat situations. What else is worth mentioning when talking about armored Hummer vehicles? There are several technical considerations to bear in mind. Military Hummer versions often feature specialized camouflage coatings that help them blend into the environment. This is crucial for enhancing survivability on the battlefield, where every detail can make a difference. Interestingly, the Hummer is not a static vehicle. Its design allows modifications based on mission needs. These can include additional weapon systems, medical equipment, or other specialized modules, depending on the task at hand. A military Hummer can carry up to 2,500 pounds of cargo or tow up to 7,500 pounds. Producing armored Hummer vehicles is a complex and lengthy process that demands highly skilled engineers and advanced technology. Everything starts with meticulous planning. Engineers account for every aspect, from improved mechanical components to resilience during blasts. Multiple prototypes are built, each undergoing a battery of tests. They are dropped from heights, fired upon, and examined for endurance in different conditions. Previously, AM General, the company that originally created the legendary Humvee, was in charge of production. However, in the year 2020, the license to manufacture new military vehicles was granted to Oshkosh Defense. As a result, combat Hummer vehicles are gradually being replaced by the Joint Light Tactical Vehicle, a more modern armored off-road vehicle. Therefore, military and civilian versions are produced separately, using different factories, technologies, and even materials. The body and armored panels are cut using laser or plasma machines, and then they are welded by robots and highly qualified specialists. Precision is crucial, because all seams must be airtight to enhance blast resistance. The Hummer is built on a robust steel frame, designed to withstand high loads. The chassis and engine are assembled separately, then tested for functionality. Only after that are they joined with the body. Once the main parts are put together, the vehicle is fitted with armored panels and additional protection. This stage is time-consuming because every component must be installed with the utmost precision. The interior of a military Hummer is nothing like that of a civilian vehicle. Everything is dedicated to functionality. Some models have air conditioning, which is essential in desert conditions. After assembly, the vehicle is painted with special scratch and corrosion-resistant paints. Several options are employed. desert camouflage for sandy regions, woodland or urban camouflage for the respective environments, and anti-radar coating to reduce visibility on radar systems. This is no ordinary paint. It is formulated to withstand heat, freezing temperatures, and the impact of blasts. The high-mobility multi-purpose wheeled vehicle is not produced in the same way as mass-market civilian cars. It is manufactured in relatively small batches, so fully automated production is impractical. At the same time, certain processes, such as welding and painting, are streamlined by a conveyor system for speed and consistency. Each high-mobility multi-purpose wheeled vehicle is equipped with a 396 cubic inch diesel engine that outputs 190 horsepower. This powerful diesel engine is engineered to operate under extreme conditions. The transmission is a 4-speed automatic adapted for off-road use. The vehicle has permanent four-wheel drive and automatic differential locks. It accelerates to 37 miles per hour in approximately 17 seconds. It is slow, but speed is not the main goal for the military. For military transport, the priorities are off-road performance, reliability, and endurance. The high-mobility multi-purpose wheeled vehicle is not designed for swift maneuvers, but for traveling over any type of terrain. It has a high ground clearance of 16 inches, which allows it to clear rocks, ditches, and logs. Full-time four-wheel drive and differential locks prevent it from getting stuck in mud or sand. The engine and fuel system are protected to withstand fire and blasts. There is minimal onboard electronics, meaning fewer things can break down in the field. It can continue moving on punctured tires. Special inserts allow driving even after the tire has been hit by a bullet. Its payload capacity allows transporting ammunition, injured personnel, and weapons ranging from machine guns to anti-missile systems. It may not be the fastest ride, but it will get you where others simply cannot go. The standard military high-mobility multi-purpose wheeled vehicle initially did not have armor, but since the year 2000, most models have received protection against small arms fire and shrapnel. Configurations vary, from soft body transport versions to the most widespread ones, capable of withstanding a high explosive device blast of up to 13 pounds. There are models with protection systems against chemical, biological, and nuclear weapons. Assembling a single high-mobility multi-purpose wheeled vehicle takes from 3 to 5 days, depending on the armor. At the AM General facility, where they build the high-mobility multi-purpose wheeled vehicle, there can be up to 3,000 workers in one workshop. However, only about 25 or 30 individuals work on assembling a specific vehicle at any given time. These include welders, mechanics, electricians, and armor specialists, each carrying out their tasks at each stage of the production line. The more complex the version, the more time and personnel are required. Before they are shipped, all high-mobility multi-purpose wheeled vehicles undergo 310 miles of test trials across off-road terrain, water, and dust. You already know how the Hummer is painted, but allow me to elaborate on the special matte paint known as chemical agent-resistant coating, which has several important properties. It does not reflect infrared light, making it harder to detect the vehicle with thermal imaging and night vision equipment. It resists chemical attacks. Its formulation makes it easier to wash off hazardous substances following chemical contamination. It withstands scratches and corrosion, enduring impacts from branches, sand, rain, sun, and aggressive liquids. The matte finish eliminates glare, which is critical for battlefield camouflage. The painting process involves multiple layers that are applied to the aluminum body and armored panels.